What is the last topic? In carbohydrates. C2Epimers. Once you tell me relationship between all these things. D-glyceraldehyde. D-glyceraldehyde. You tell me. D-erythrose. D-erythrose. D-triose. D-triose. Next. D-ribose. D-arabinose. Arabinose. D-xylose and D-lysose. D-xylose, D-lysose. Next here what I given? D-glucose, D-mannose. D-glucose, D-mannose. Here D-galactose and D-thallose. D-thallose. Erythrose, triose. Which epimers? C2 epimers. T-ribose, D-arabinose, C2. T-xylose, D-lysose, C2 epimers. Okay, and these two are C2 epimers. These two are C2 epimers. I said to remember the pairs. Okay. Next, D-erythrose is which aldotetrose. Aldotetrose. All these are aldopentoses. Aldopentose. Aldohexose. So glucose is aldohexose. Aldohexose. And what is the relation between these two? 2-glucose and D-galactose. Which epimers these are? C4 epimers. C4 epimers. Right? And we completed structural illustration also, structural analysis also. Right. In the last class. Once look at this. Glucose. So write the formula. C6H12O6. Glucose when treated with HCN or NH2OH produce cyanohydrin and hydroxyl amine. This reaction confirms presence of. Can we write like this? Carbonyl group. Generalization. Carbonyl group. Glucose when treated with bromine water gives gluconic acid. What is the structure of gluconic acid? How many carboxylic acid groups are present? How many? Gluconic acid structure. One carboxylic acid is present. Gluconic acid. This reaction confirms presence of aldehyde. Glucose when treated with HNO3 gives saccharic acid. Correct only, no? Gluconic acid, saccharic acid. Saccharic acid contains how many COOH groups? 2 COOH groups. Glucose. This reaction confirms presence of primary alcohol. Okay. HNO3, primary alcohol converted to COOH. Product name N-hexane. And when it is treated with H2 nickel, sorbitol. With AC2O, acetic anhydride, it gives penta-acetyl derivative. That in the last class we completed this, right? Okay. Next, cyclic structure of glucose. Cyclic structure. What are the evidences for the cyclic structure of glucose? cyclic structure of glucose. Glucose C6H12O6 gives, tell me online students, when glucose treated with NaHSO3, what is the product? Skips base 2,4-DNP, 2,4-dinitrophenyl hydrogen. Glucose do not give any product with these three reagents. Glucose do not react with the skips base, do not react with 2,4-DNP, do not react with the sodium bisulfite. Okay. This is the evidence for the cyclic structure of glucose. See, glucose contains aldehyde, but why it is not giving reaction with sodium bisulfite? Aldehyde's characteristic property is the nucleophilic addition, right? Aldehyde ketone characteristic properties. But why it is not giving? Even though glucose contains CHO group, but it is not reacting with NaHCO3. If CHO is present in any compound, that will react with NaHCO3. If CHO is present in any compound, that will react with skips base 2,4-DNP. But glucose do not react with these three. Means aldehyde is present, but that is not present in the free state. So glucose is present in the cyclic structure. Free aldehyde group is not present. That's why it is not reacting with NaHCO3, skips base and 2,4-DNP. Right. In the last class, I given how many moles of phenylhydrazine is react with glucose. How many moles of phenylhydrazine? I forgot to revise that also actually. How many moles of phenylhydrazine I have to write here? NH2, NHPH. How many moles? 1 mole of glucose react with how many moles of phenylhydrazine? 3 moles of phenylhydrazine. I given the mechanism also, right? 1 mole is utilized to react with the aldehyde. Second mole is to oxidize OH. Okay, right. That is also important point. Actually, I forgot to revise that. Next, continuation. Okay. Glucose is present in the cyclic structure. Let us see the cyclic structure directly and how cyclic structure formation takes place. CHO. This is open chain structure. See, I will tell you one trick to draw the structure of glucose. First of all, draw one vertical line. One vertical line. Keep CHO at the top and CH2OH at the bottom. OH group at 5th carbon attacks aldehydic carbon. This is like a nucleophilic addition. You know aldehydes properties. Aldehydes react with the nucleophile. Nucleophile attacks carbon because this is having positive, this is having negative. You know nucleophilic addition reactions. See? C double bond OH, aldehyde. CHO, C double bond OH. OH group at 5th carbon attacks carbonyl carbon of the aldehyde. This is also question. Cyclic structure is formed due to attack of which OH group? OH group at 5th carbon. At that time this bond will go this side. Okay. Then C, oxygen with a negative or positive? Negative or positive? Bond is shifting to oxygen, negative charge. H. How many horizontal lines? 1, 2, 3. Let us write 4 later. Okay. These structures are as it is: OH, H, OH, H, OH, and H. Right. Now look at this. Okay, this oxygen is connected to carbonyl carbon. Okay, and here hydrogen. One hydrogen is present on oxygen. Right? Why I wrote positive charge? Because oxygen is giving its pair of electrons to carbonyl carbon. Right? But oxygen with a positive is stable or unstable? Unstable. So this hydrogen will shift. This hydrogen will shift towards the oxygen. At that time, this bond will, this carbon oxygen hydrogen bond shifts to oxygen, and the positive charge will be nullified. So I am writing directly. Okay, this is the cyclic structure. 1, 2, 3, 4, 5, 6 carbons. How cyclic structure is formed? When OH at 5th carbon attacks a carbonyl carbon. Okay, right. Now let us draw very important structure, Haworth structure. Haworth structure for glucose. Haworth structure. Before starting Haworth structure, you should understand this. This is pyran. Pyran. This compound name is pyran. Haworth structure is similar to pyran. Let us draw pyran. Okay. See. These structures are very important to draw the disaccharide structures. Disaccharide structures are important because links will come in the exam. Links. How two monosaccharides link together. You should know this structure. I will tell you one trick to you. First of all, give numbering. Very easy to draw this structure. Give the numbering. 1, 2, 3, 4, 5. First carbon, second, third, fourth and fifth carbon. Okay. At first carbon, OH is present on which side? Left side. This is tetrahedral, right? Carbon is surrounded by how many bonds? 4 bonds. 1, 2, 3 and 4. Tetrahedral. Tetrahedral means we can interchange any atom or group. Clear? So can I write like this also? This form also important, but first start with alpha. When OH group is present on the right side, that is called alpha. First carbon OH. If present on the right side, that is alpha D glucopyranose, because this is similar to pyran structure. In the pyran structure, in the ring oxygen is present and 4 carbons are present, so pyranose, similar to pyranose, so alpha D glucopyranose, its name alpha D glucopyranose. This is alpha D glucose, glucopyranose. Right. At first carbon, OH is present on which side? Right side. So the groups which are present in the right side should present below the plane or below the ring actually. Consider this is a 6-member ring. Okay. Below the ring and above the ring. The groups which are present on the right side will come below the ring. At first carbon, OH is on the right side. At second carbon also OH is on the right side. So at second carbon also OH is down. At third carbon, OH is left. At fourth carbon, right again, right. At fifth carbon, always CH2OH is up only. CH2OH is up only. Okay. Alpha D glucose, alpha D glucopyranose, alpha D glucose, alpha D glucopyranose structure. Clear? Now see the trick. First of all, draw the 6-membered ring. 6-membered ring. I will show you. Draw 6-membered ring like this. Give the number 1, 2, 3, 4. 1, 2, 3, 4, 5. At two ends for alpha, keep OH down, OH down. Easy only, no? At two ends, keep OH down for alpha D glucopyranose. Alpha D glucopyranose. Okay. In the middle, keep two OH groups in the opposite directions. Opposite, over. At the two ends, two OH groups are down for alpha D glucose. In the middle, two OH groups are opposite, but be careful. First and second OH should be down. Okay? OH, OH. Continuation, OH, OH. Where it is? These two are on the right side, na? So down, 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 down. Okay? At fifth carbon, CH2OH and H. Clear? No doubt. At two ends, OH groups are down. In the middle, OH groups are opposite. What is its name? Alpha D glucopyranose. Alpha D glucopyranose. Look at this. Why it is called as alpha D glucopyranose? Why it is called as alpha D glucopyranose? OH on the first carbon is right side alpha. Can we draw beta D for this? Let us draw beta D. See, OH, H, CH2OH. Alpha D glucose, this is beta D glucose. Beta D glucose. Beta D glucose. Right, it's Haworth structure. Haworth structure. You tell me. One, two, three, four, 5. In alpha D glucose, two OH groups down, but in beta, at first carbon OH is on the left now, so here remaining structure is same, just here only you are changing. Here only you are changing, right? Remaining structure is same. At first carbon only difference will be there. Remaining are same. No change in the remaining atoms position. Clear? This is CH2OH. What is the difference? Difference will be at a first carbon only. Sorry. Alpha, beta. Alpha means, that is only I am saying. No? Alpha means OH at first carbon is on the right side. D stands for, did you listen yesterday's class, Adiba? Explained in the yesterday's class what is D and what is L. Alpha means at first carbon OH is on the right side. Capital D means, capital D means from the bottom to top. If you go from bottom to card, if OH is on the right side, that is capital D, capital L. Alpha D glucose, beta D glucose are the cyclic structures. Where these two are different, where these two are differ, at which carbon they are differ? At which carbon they are differ? At first carbon. At first carbon. The carbohydrates which differ at first carbon are called as anomers. Are called anomers. What are epimers? Which differ at second, third, fourth, any carbon, not only at second carbon. C4 also, na? Glucose and galactose. Anomers are the carbohydrates which differ at first carbon only. Epimers are the carbohydrates which differ at any carbon other than first carbon. So, alpha D glucose and beta D glucose are anomers. 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 Which two are anomers? Alpha D and beta D glucose are anomers. And these are the Haworth structures. Alpha D glucopyranose, this is beta D glucopyranose. How to draw the structure? Imagine alpha D glucose, two ends OH down, in the middle OH are opposite. Clear? Next. Labridi, Bruyan, Van Akenstein. Did you listen this? Reaction or rearrangement? Labridi, Bruyan, Van Akenstein rearrangement. Sucrose formula C12H22O11. When sucrose is dissolved in water, it produces glucose and fructose. Formula of glucose and fructose are same. C6H12O6 only. I will give you fructose structure. Fructose structure. Then we will go with this rearrangement. Glucose is our glucose alpha D forms, beta D forms, cyclic structures. How a cyclic structure is formed. Clear? In your syllabus, this rearrangement also there. Regarding fructose, that structural analysis is not important, but know the structure of fructose. Okay? Let us draw the structure of fructose, then we will go with the above rearrangement, because in the above rearrangement we use fructose structure. First we take fructose structure and we will get glucose. Right? See fructose. What is the fructose formula? C6H12 and O6. See. CH2OH, C double bond O. In fructose, ketone is present. In fructose, which is present? Ketone is present. Ketone is present. This is cyclic structure. Cyclic structure. This is D, capital D. D form. Why this is capital D? Why this is capital D? At a second carbon from the bottom, OH is on the right side. See this part. OH is on the right side. D form, L form, D form. If OH is on the left side, capital L form. Okay. What is its name? D fructose. D glucose or D fructose. D fructose. Let us draw cyclic structure. Cyclic structure. Give the numbering. 1, 2, 3, 4, 5, 6. Okay. Similar to that of glucose. Fifth carbon OH group attacks C double bond O. C double bond O. To form, I am writing directly OH on the right, this CH2OH on the left. Okay. Remaining 1, 2, 3. CH2OH. Tell me here. This is over right. This one H, OH. OH, H, H. D. See. pyranose word is used in glucose. This is furan. Furan. And OH is present on the right side. So alpha D fructofuranose or furanose, alpha D furanose form. I'll tell you what is a furanose. This is furan. This is furan. Pyrrolofuranothiophene structures. This is similar to furan, so we use furanose. Furan word, furanose. Okay, alpha D fructofuranose, furanose form. Can we write beta D form also? This is on the right side. Put OH on the left side. C OH CH2OH. The remaining structure is as it is. Just you are changing at a second carbon. This carbon. Let us consider numbering 1, 2, 3, 4, 5, 6. At second carbon only difference will come. The remaining structure is same. Okay. H OH OH H H. And this is CH2OH. This is beta D furanose. Beta D furanose form. Okay, now let us draw Haworth structures. How to write Haworth structure? The group which is present on the right side will become in the down. This is first. Give numbering from the second onwards. At second carbon, OH is on the right side. So OH CH2OH. Okay. Third carbon, OH H. At fifth carbon, CH2OH is always up. Okay. Alpha D fructofuranose. Complete name is alpha D fructofuranose. Furanose. Why we are calling it as a furanose? It is similar to furan ring. Beta D. Tell me fastly. Beta D will present like CH2OH OH. At this carbon CH2OH is always up. Beta D fructofuranose. Okay. Alpha D fructose or furanose form. Beta D fructose or furanose form. Alpha D fructofuranose. Beta D fructofuranose. If you feel any difficulty in learning all this, remember the structures directly. How we wrote glucose structure? Tell me. How we wrote glucose structure? Two OH groups down, in the middle opposite. Here in the beta OH will come up. In the middle OH groups are opposite only, but first OH will come up. But in glucose, OH is down. That is the difference. At fifth carbon, CH2OH is always up only. Okay? Right. What is our heading? See? What is our heading? Labrie-de-Bruijn-Van Ekenstein reaction. We will take a fructose structure, and we will get a glucose or mannose. The rearrangement of fructose in the presence of base to glucose and mannose is called as Van Ekenstein reaction. Labrie-de-Bruijn-Van Ekenstein reaction. Clear? See, fructose do not contain aldehyde group. Yes or no? But why fructose gives stolen stress? Due to this rearrangement only. See that rearrangement. First take fructose, CH2OH, C double bond O, OH. This is fructose. Very simple reaction. This is Labrador Van Ekenstein. OH minus capture hydrogen. Can we write hydrogen, one hydrogen separately? Look at this. Write this hydrogen separately. This OH minus attacks hydrogen, means proton only will go towards base. Then what is present on the carbon atom? Negative charge. Okay. This OH minus captures H, hydrogen. Remaining structure CH negative, OH, C double bond O, and this remaining structure is as it is. You just leave it, okay? Put in a box. No need to draw. Clear? Any doubt in this? Base capture proton. Next, this negative charge participate in resonance. Okay. Tell me. CH, this is double bond. C, negative charge, and this is common. Here, O, H, O bond H or OH. OH can be written as O bond H, right? Next, proton transfer, H plus transfer will take place. What is the source of H plus? OH minus and H plus, H2O. OH minus capturing proton, so H2O is formed. From that time we are transferring H plus. You tell me. Tell me remaining structure. CH double bond C, OH, and remaining structures. Right? You know tautomerism? In stereochemistry, this bond will shift in between these two. Double bond shifts to carbon. Now carbon will get which charge? Negative charge. This proton attacks that carbon atom. So gives to CH double bond O, single bond CH OH, and the remaining structure is as it is. This is glucose. CHO, which is on the right, which is on the remaining structure is common. So glucose is formed. Because this is sp3 carbon, we can keep OH on the left. Mannose is also produced. Just see and leave it. Okay. Because of that point, in fructose, aldehyde is not present, right? But why it gives Tollens test? To give the answer for that, I explained this rearrangement. Here you no need to learn. In the presence of base, fructose is converting into what? Tell me. Fructose is converting into glucose. In Tollens test we use base also. Tollens test is prepared by using base. In the presence of base, fructose is converting into glucose and mannose, and aldehyde group is generating. That's why fructose gives positive stress with Tollens reagent. It is a reducing sugar. Fructose is a reducing sugar. What is the reason? In the presence of base, aldehyde group is generating. Clear? This is Labrador-Van Ekenstein reaction. Custom undi kada? Right. But important point, what happens in that rearrangement or reaction? Fructose will convert it to glucose and mannose in the presence of base. Just observe that point. Clear? Right. Now you tell me, when we use fructose we are getting glucose and mannose. Similarly, when you drop alpha D glucose form, first that cyclic chain will open. When you pour alpha D glucose form in water, that open chain will break, that chain will break and open chain is formed. Then beta D formation takes place. Interconversions. Look at this. This is alpha D glucose, right? Take alpha D glucose crystal, put in water, dissolve in water. First this chain will break, open chain formation takes place, and from that open chain beta D formation takes place, means interconversion. Alpha D glucose will convert it to beta D glucose when you keep separately alpha D form in water. For example, take the crystal solid of alpha D glucose, put in water, dissolve it. First this chain will break, you will get open chain, then beta D formation takes place. Clear? Look at that also. Alpha D glucose, open chain form, and beta D glucose. If you take beta D glucose in water, again same phenomena takes place. That's why given reversible reaction. What is alpha D glucose and beta D glucose? What is the difference? Difference is which carbon? Alpha, first carbon. Clear? Right. Alpha D glucose is having one specific rotation. This is optically active compound or not? This is optically active only, no? This is having some specific rotation. For example, 112 degrees centigrade. It rotates light by 112 degrees centigrade. Just to consider. It is having some specific rotation. Which one? Alpha D glucose is having some specific rotation, optical activity. Specific rotation means rotation of light towards right or left. When you keep alpha D glucose in water, what is happening? Beta D glucose is forming. So beta D glucose is having some other specific rotation value. For example, take 19 approximately. I am considering, not exact values. Clear? It is having some specific rotation. It is having some specific rotation or not? What is specific rotation here? 112. After some time it is changing to 19. This change is called as mutarotation. What is definition of mutarotation? The change in the optical rotation or specific rotation of a compound with the time is called as mutarotation. For example, you have alpha D glucose in your hands. What is its rotation value? Specific rotation value? 112. Some angle. When you drop that alpha D glucose, if you wait for some time, its specific rotation value is changing to other value. That rotation is called as mutarotation. Clear? Mutarotation is shown by reducing sugars. Only, not with non-reducing sugars. Clear? Remember mutarotation concept, and values are given in the PDF. Exact values you can see that PDF. Did you get the definition of mutarotation? The change in the specific rotation of a compound is called as mutarotation. Okay. Next, last topic and question coming area in tomorrow's exam: structures of disaccharides. Links, very, very important. Okay. %, this question will come in the tomorrow's exam, no doubt. Links. First, what is first one? What is the code for disaccharides? Small. Sucrose, maltose, lactose. Structures, links will come in the tomorrow's exam. Link or directly will get the structures. Identify the structure of sucrose like that. Okay. What is the formula? C12, H22, O11. When it is dissolved in water, what we will get? C6, H12, O6 plus C6, H12, O6. One is glucose and one is glucose and fructose. Sucrose. Let us see sucrose properties. Sucrose is a reducing sugar or non-reducing sugar? Non-reducing sugar. Why it is non-reducing sugar? Because it is non-reducing sugar. Will it show mutarotation? Do not show. will not show mutarotation due to absence of anomeric OH group. Free OH group is not present at anomeric carbon in sucrose. Will not show mutarotation. Non-reducing sugar. Coming to the structure. Structures are very important. Composition. How it is composed. Glucose and fructose. Which glucose, which fructose? Alpha. We have alpha forms, we have beta forms. Clear? Right. Alpha D glucose plus beta D fructose. Alpha D glucose and beta D fructose. And link also. First of all, write alpha D glucose. You know how to write alpha D glucose? I said one shortcut. First draw a 6-membered ring. Tell me what we have to write. Alpha. OH down, OH down. In the middle, opposite. CH2OH is always up only. Now give the numbering. 1, 2, 3, 4, 5 and this is 6. Alpha D glucose or glucopyranose. Alpha. Alpha D form. Next, what is next? Beta D fructose. You tell me how to draw fructose structure. Beta means which is top. Without question on these structures, no paper tomorrow. Pakka links will come. Links. I'll tell you what is that link. 4th carbon. At this OH is down or up? Up. Opposite. Opposite. At 5th carbon? Always up. Right. Now see the preparation method. Preparation or hydrolysis property. When you add water, what you will get? If you add water to sucrose, what you will get? Remove water from them. Remove water from these two, you will get a sucrose. Reverse. Reverse. If you add water to sucrose, you will get these two. If you remove water from these two, you will get a sucrose. So remove water. But from which two? First carbon C1 and give numbering 1, 2, 3, 4, 5. Second carbon OH and H minus H2O minus H2. Okay. So I am not writing remaining all structure, just highlighting the positions where these two are linking. Okay. Water is eliminated or not? One oxygen atom is there. Here CH2OH. The link through oxygen is called as glycosidic link. This is called glycosidic link. You know, in biology it will come glycosidic link. Glycosidic link. Glycosidic link. Where this link is forming? C1 and C2. C1 of which form? Alpha. C1 alpha and C2 beta glycosidic link. Glycosidic link. This link will come. Okay. In glucose, which carbon is linking? First carbon. In fructose, which carbon is linking? Second carbon. C1 alpha, C2 beta glycosidic link. Alpha beta glycosidic link. Alpha beta glycosidic link. Clear? So learn how are the structures. You know already. You learned already. And remove water molecule from them. Very easy. Right? Okay, sucrose structure is over. Next, maltose. Maltose. Online students, are you following? Hello, following or not? Maltose. Maltose. What is the formula? C12H22O11. Maltose. Maltose. Formula is same. Sucrose, maltose, lactose formulas are same. Right, you tell me. Same. Ending with the word M. Means this is composed of same units, similar units. That is the trick. Maltose is made up of similar type of units. What are the units? Maltose upon hydrolysis produce C6H12O6 plus C6H12O6 same. So glucose here, glucose no, same M. Glucose only. Composed of 2 glucose units. That's why given this trick, same. Clear? Right. Alpha. Both are alpha forms only, but where a link will form, that is the question. Okay? Okay, write some points. Say some points about this, then we write. This is reducing sugar or not? In disaccharides except sucrose, remaining are reducing sugars. Reducing sugar. It shows muta rotation because free OH group is present at anomeric carbon. Sucrose do not show muta rotation due to absence of free OH. Right? Shows muta rotation. Shows muta rotation. Muta rotation means change in the specific rotation. Right. Once again, practice for you. How to draw the glucose structure? Cyclic form. OH, 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 H. Here, sorry, here CH2OH. Alpha D form, alpha D glucopyranose. Another unit also glucose only, na? So write another unit here, side by side. Alpha, remove water from them. Two numbering 1, 2, 3, 4. 1, 2, 3, 4, 5. Where link is forming? C1 alpha, C4 alpha. Alpha glycosidic link. C1 alpha and C4 alpha glycosidic link. Remove water. Remove water and keep O in the middle. Okay. Online students, got it? Both are alpha only. Where link is forming? 1 and 4. In glucose, in sucrose, 1 and 2. 1, 2. Alpha beta glycosidic link. There. Clear? Next, last one. Lactose. Sucrose, maltose and lactose. Lactose formula is same. C12H22O11. C6H12O6 plus C6H12O6. Glucose and galactose. Glucose and galactose. Lactose is made up of glucose and galactose. Beta forms, not alpha forms, beta forms. You tell me glucose and galactose are which epimers? Which epimers they are? C4 epimers. First of all, I wrote a beta D glucose, beta D glucopyranose. In alpha, OH will down. In beta, OH is up. Remaining is same. Everything is same. This is alpha D glucose or glucopyranose. Galactose. See, that's why I mentioned at the classification. Due to this reason only. Glucose and galactose are which epimers? So where structure will be different? At the fourth carbon. At the fourth carbon only. So 1, 2, 3, 4, 5. At the fourth only we have to change. Remaining is as it is. OH, H, OH, H, OH, H. This is fourth carbon. 1, 2, 3, 4. Fourth carbon. OH is down. Here OH is up because glucose and galactose are C4 epimers. C4 epimers. At fifth carbon CH2OH is always up. Now remove water molecule from these two. Which these two? These two. Okay. Now you will get structure. I am not writing the product after removing water. You can draw the links like this. In exam, links will come like this. Remaining structures are same. Remaining here groups, here, everything. Link will come like this. You have to identify which of the following structure represents lactose. You have to identify. Okay. And what about the properties? Is it reducing sugar? Yes. Shows beta-rotation? Yes. Except sucrose, the remaining two will show beta-rotation and the remaining two are considered as a reducing sugars. Okay. Go through the PDF perfectly.